Hello everyone and welcome to WintellectNOW. Imagine for a moment that you're Ansel Adams and you're out west in the Yellowstone and Tetons area and you're trying to capture the beauty of the mountains and the rivers and the streams and the meadows and the wildlife in that area. But you're limited to black and white photography on a rather primitive camera that requires completely manual operations to run. In order to capture the beauty of that area, you have to both understand the science of the camera as well as the aesthetics of what makes beautiful photography. Ansel Adams was a master of both. He understood the technical details of everything that he was doing. He knew how to adjust the aperture and the shutter speed of his particular camera. He understood how to process the photo once he had taken it. He understood what medium to use under what certain lighting conditions that would best capture the dynamics of that particular scene. But not only did he understand the technical details of it, he also understood the aesthetics of what makes beautiful photos. He understood how to apply the rules of composition effectively and represent those in landscape photographies. And his photography has endured for a long time because of that. He was able to capture some beautiful scenes that have been replicated over and over and over and are still studied in depth by photographers even today. I think there's a lot of parallels between photography and software development. There's an art to software development as well as a science. The science would be, the nuts and bolts of programming, how to build data structures, how to make logic flow, how to get data into that program and out of that program. And you can construct rather robust programs with a very, basic understanding of how the nuts and bolts of programming. But programming does get a lot more complex when you get beyond just basic programs. And sometimes if you get into more really complex programs, you end up with many programs call just a big ball of mud or spaghetti code, where it's incredibly convoluted, hard to understand, and is incredibly complex. Now, what software developers have experienced over the years is that as a way of developing software is not a good way. It's not conducive to anything that would be it's not conducive to reusability or maintainability or even simplicity. And so what they've done is they've tried to take a step back and look at this from a different angle and try to understand what principles can we apply to the science of software development and make an art out of it so that we end up with something that's beautiful rather than just a big ball of mud. And these principles that they have kind of abstracted out of experience are what we call design patterns. Design patterns aren't particular to any programming language, so long as a language is object-oriented and it can use design patterns. And PHP is object-oriented, so obviously it can use design patterns. The purpose of this video is to take design patterns in PHP and put those into a single context so you can begin to see how PHP can employ design patterns in an object-oriented context so you can begin to build beautiful software using PHP. In addition to this, you're also going to get to see some new APIs that you may not have seen already, and also see how software might begin to bloom out of the PHP environment so you can begin to build applications that are well designed in PHP. So what are design patterns anyway? As the name implies, design patterns are reusable solutions to common problems in software design. As I said earlier, what experts have done is they've taken their knowledge and from that abstracted from it general principles that they can apply across different kinds of software no matter what the nature is, but the pattern can be applied regardless of the nature of the software, whether it be an email app or a game or even a website. These patterns seem to be reusable, and so they've collated these and created what have become known as design patterns. Now, design patterns are generally applied at the module level. When I say the module level, I'm really talking about the class level. I want to be clear about that because a design pattern isn't necessarily an architectural pattern. An architectural pattern is an overarching pattern that is applied to an entire piece of software, such as MVC or MVVM, and then talks more about how whole suites of classes interact, not so much particular classes down and a little bit more in the details, which is where design patterns typically dwell. And the purpose of design patterns, as I said, is to facilitate and organize the interaction of objects in an efficient manner rather than having spaghetti code or a big ball of mud, as I keep saying. Rather, have something that is rather segmented, as what we like to say, decoupled, and something that is efficient. So it's actually simpler than having something that's connected in every such way to another class or another piece of code that is hard to separate those or even reuse that. So to kind of get that in the back of your head, that we're looking for reusability, simplicity, maintainability, and all these things that we consider to be important to software design and whatnot. Perhaps the seminal work on modern design patterns comes from the book Design Patterns: Elements of Reusable Object-Oriented Software. And this book is by four authors known Eric Gamma, Richard Helm, Ralph Johnson, and John Felicities. And these four authors have collectively become known as the Gang of Four, and the patterns that are in this book have become known as the Gang of Four patterns because of the authors. This book, while it's 20 years old, is still widely popular, and the reason why is because the patterns in this book were collated in such a way that a lot of people, when they started picking this book up and reading it, said, oh, this is really good stuff, and it has gone to influence several books that are available on the market even today. Even though this book is 20 years old, it is still widely used in software design, and it has the Addison Wesley label on it, but don't let that academic label scare you. Don't think of this as a software engineering 101 book that you can throw away once you're done. In fact, I was foolish and threw away my copy whenever I graduated from college, saying I'll never need this again. But I was foolish. When I got down the road, I ended up having to buy the book again because of that. So I would encourage you, if you're interested in design patterns beyond this video, to pick up a copy of that book and just read through it. It starts off with a case study and why they believe design patterns are the way they are, and then it goes on to talk about the 23 design patterns that have become known as the Gang of Four patterns. And then you could see how these design patterns are still widely used today and even implemented into the bedrock of many languages that are modern, even in today's modern programming languages. So highly recommend this book to anybody that's interested in design patterns. The purpose of this video is to take these design patterns and look at them in the context of PHP. Now, the 23 patterns in the book are using Smalltalk and C++, but I'm going to look at these 23 same design patterns and use them in PHP, but also looking at them using some modern technologies such as HTML5 and whatnot, and then also in the context of PHP object-oriented design in PHP version 5 and beyond. So buckle your seatbelts. This is going to be a lot of demoing these 23 patterns that are inside of this book. Before I start talking about design patterns, though, I want to talk a little bit about what has become known as anti-patterns. Now, anti-patterns really have nothing to do with code. They really are bad habits that developers employ when they actually start writing software, and they're counterproductive. They don't really help. One of the first ones of these is post hoc design patterns. Now, in the context of design patterns, when you actually start writing software, you're supposed to employ the design patterns before you ever write the first line of code. So when you actually start thinking, you're in the design phase of a piece of software, you're supposed to think about organizing objects and how these are going to relate together on a whiteboard or on paper first, and then you come back and you actually start writing code. Now, a lot of times some people will go back and they will look at a piece of a project they've already completed and it's gone on to testing and deployment, and they said, oh, it would be great if I could employ a singleton here, and they go back and deconstruct the entire application just so they can put a design pattern in it. That's not the time or place for that. Design patterns are in the design phase, not once the software has been written. Now, after you're going into the next version, version 2 and version 3, and you're starting to refactor it, maybe you can implement it then, but not after the software has been written do you want to start implementing design patterns at that point in the game. A second anti-pattern is patterns for pattern's sake, or the, hey look, I implemented a singleton factory and bridge pattern all while using the observer pattern to get my app to print hello world. Sometimes this is called gold plating, or it's just really trivial use of design patterns. It's really not good design at all. It's actually poor design. If you're just employing a pattern just so you can say you used it, it's probably the case that you don't need that pattern. In fact, and probably better if you didn't use the pattern, if you're just employing it for pattern's sake. So think about the pattern long and hard before you actually start implementing your software. Do I really need this? Does it really make my program more efficient? Or am I just doing this so I can say, hey, I used a design pattern in my software, look. A third anti-pattern is called cargo cult programming, or cargo cult design patterns. That's using design patterns without actually knowing what they're for or how to use them, or not really understanding it. because some star programmer on your team or one of your favorite developers used a particular design patterns, you think, oh, that's cool. I can cut and paste this in my program, not really understand what it's doing, but hey, look, I got a design pattern, and so said it was good. Martin Fowler said this design pattern was awesome, so I used it. And that's really not understanding what it's for or how to use it. That's just, copying somebody because some expert or somebody that you really admire used it. That's cargo cult programming in that respect. And a fourth anti-pattern is the golden hammer anti-pattern. The golden hammer anti-pattern is essentially the idea that somebody's got the magic tool to fix everything with. And some developers get in their mind that they use a pattern so much that they think that they can employ it in every piece of software they write. Well, that's not the case. You don't have to employ the same patterns in every software that you write. In fact, sometimes some software are more conducive to certain design patterns and not conducive to others, and then the next piece of software you might write might not even use any of the design patterns used in the previous software that you've written. So the idea of design patterns is so when you start looking at a problem, you say, oh, this pattern really fits here. I think I can write my program and employ this pattern here, and it really does help. But some people will try and use a pattern just because they've used it over and over and over again to solve multiple other problems. And a lot of times, some of these patterns do crop up more than others, but it doesn't mean that that it's going to solve every problem that you've ever had in designing software. And the last one is a golden slipper programming, which is similar to golden hammer, but it's an attempting to use a pattern when it simply doesn't fit. Sometimes design patterns are used for certain types of problems, but you might have a similar problem. So you think, oh, I can just employ this design pattern and solve this problem. Well, sometimes that doesn't work. In fact, when I was writing a lot of my demos on here, I was trying to come up with a context in which I could actually employ the design pattern, a problem in software development that could actually employ a pattern. And once I got started writing a few lines of code, I realized, oh, this pattern really doesn't really solve this problem. And in fact, I'd actually have to kind of shoehorn it in there to make it work, and it just didn't seem to go natural. And that's what I thought about, golden slipper programming. It just didn't fit the problem. So I wasn't going to try and shoehorn it. I just tried to come up with a different problem that the design pattern would solve. In fact, when I was writing software for this demos here, I was actually trying to find problems to solve with the design pattern, not trying to solve problems with the design, and not employing patterns to solve the problem, but trying for problems that the pattern actually solves. So I was actually kind of doing it backwards. I was doing that for demo purposes, but in real life I would actually go about thinking about a broader context and saying, what patterns, if there is one, can I employ to solve this problem? If there's not, then perhaps I need to make a new pattern or something like that. But golden slipper programming is when you actually try to force a pattern to fit when it actually doesn't. The Gang of Four patterns are divided into three categories. The first category is creational. Creational patterns are used, as the name implies, to create objects. Rather than create objects directly by calling their constructors, creational patterns assist in creating objects by providing intelligence to object creation. Now, this is typically done by, instead of having a constructor called, what you do is you call a method in a certain class, and then that method's purpose is to actually return a particular instance of a certain kind of object. And we'll see how this is done when we actually start looking at some of these creational patterns and how this can be very useful in object-oriented programming. The second category is structural. Structural patterns combine and compose objects together to get new functionality. And what this does is it helps create simpler objects that you can put together to create complex structures. So it actually helps reduce on inheritance and subclasses and helps reduce the number of actually different kinds of objects you have. And it creates a simpler application, but when you combine these, you can actually represent complex data without having to have tons and tons of subclasses beneath a single parent class. So we'll see how that works when we actually start looking at some of these structural patterns as well. And the last category are behavioral patterns. Now, behavioral patterns are patterns that facilitate communication between objects. Now, one of the mantras of good object-oriented programming is decoupling. And what decoupling is, when something is highly coupled to another object, that means that if you were to remove one of the objects, it's likely that the other object would become useless or almost useless. Well, what decoupling does is it attempts to minimize the dependencies between various objects. And what these behavioral patterns attempt to do is just that, is to decrease the coupling between these objects and just make so the communication is a lot simpler, and so that you don't have tons and tons and tons of linkage between different objects, and so they can kind of exist independent of one another without having to worry about breakage whenever you actually start changing smaller objects and whatnot. So the behavior patterns are very useful for that, and actually help increase maintainability of code and usability and simplicity for that matter. The first pattern I want to introduce is the factory method pattern. Now this is a creational pattern, and what the factory method pattern is for is to create objects of a particular kind. Anytime a method's purpose is to create another object, it's called a factory method. And as you can think about a factory, what does it do? It creates objects. It creates things. A car factory creates automobiles. A clothing factory produces clothing. So if you can think of a factory method, its purpose is to produce an object inside of a program. So what the factory method does is it defers creation of objects to subclasses. Okay. And it can be implemented as solely a method or through an interface. So, and we're going to look at the difference, like an instance of this, but essentially it's just a method. And it can manifest itself in many different ways, but the purpose is, like I said, the factory method whole purpose is to create an object. So what it might be useful for is clearing up ambiguity among constructors. If you can imagine, if you had a particular object who might have 5 or 10 or 15 constructors, because it can take so many different parameters in the constructors, what you might want to do is, instead of having so many different constructors, is actually employ a factory method, and that receives another object, and then from that, and then inside that object is actually a parameter that you can actually spit out another object from that. It can also be used for creation of objects that need to be accessed information not available within the calling class. For instance, if there was a private variable inside of a class that's not accessible by the calling class that's actually trying to create a particular object, then you might want a factory method to call that factory method, and then it can access some data that's inside of the class in which it exists. And the last one might be when calling a class is not concerned about the details of creating an object. In other words, the calling class is only concerned about getting the object back. It doesn't really concern itself with, I want an object that's blue, that's 5 inches long and round. It doesn't care. It just says, get me a ball. It doesn't care anything about that ball. It says, get me a ball. And then the factory method would just build a ball and return that ball object back to the calling class. So that's when you might actually use a factory method. In my demo here, I'm actually going to look at a fairly trivial example of a factory method. It demonstrates it in concept, but what I want to do is show you the code, then run the demo, and then at the end of the demo, talk a little bit about when you might go about using a factory method to create objects. Okay, in this code here, you see that I've got a very simple class. I have a vehicle class, and it's got 3 properties, year, make, and model, and it's got a constructor. But you'll see here that I've got 2 static functions. Now these 2 static functions here are the factory methods inside of this class. Now, factory methods don't always show up as static methods, but often they do. That way you don't actually have to instantiate an instance of this object to get access to the method to create a particular kind of object. But for the vehicle class, I declare them as static methods. That way I don't have to instantiate the object. I just call the class and then do : and then call the factory method, static method, and it will return a vehicle. And notice it's returning a vehicle object, so this would constitute a vehicle, a factory method. And I have one for create Ford and create Chevy, and all it's doing is taking the year and model and then populating the make with whatever the make is for that respective method. So this is the actual factory methods here, and you can see I've got a utility function for display, and down here's where I'm actually using this. I'm calling inside of this, I'm looking to see if if the user actually selected a make from a menu, and then from there I'm going to case forward, call that class : and then call that static method, that static factory method, and then get back from that a vehicle object, and then I'm displaying the vehicle down here. So that's a fairly trivial example of a factory method. Let's flip over to Chrome and see what this looks like. You see here I've got my factory method demo loaded up. I've got two things in my drop down here, Ford or Chevy. I'm going to hit go, and it's going to print back car 2013 Ford Mustang. If I select Chevy, it should give me back a Chevy Corvette. So you can see here that, I mean, I've got a fairly trivial example, but it is calling that method to get back the vehicle, and I'm displaying information about it. An instance where you might want to use a factory method for something like this is if you had a complex creation logic where there was a lot of steps involved in creating a particular object. One example that comes to mind is in C# whenever I'm programming with XML. Oftentimes you have to load the XML out of a file, you have to attach it to a stream, then attach the stream to an XML parser, and then it gives you back the respective elements, the XML elements related to that. Well, wouldn't it be convenient if I just could pass in a file and then it gives me back that without having to create the stream and everything in between? Well, that's when a factory method would become very conducive. I just give it I can parameterize that and give it a file and say give me back a parsed XML document and object form without having to go through all the intermediate steps in between that. So that's when a factory method might be useful and whatnot. And in this case, that's what I'm doing. I'm just sort of kind of doing that, but I'm actually just skipping the make portion. This is trivial, but if I didn't have to, if the selection process on a make was a lot more involved, then I might not go through just creating it directly. I might actually have some more logic inside of those factory methods, but this does demonstrate what a factory method might look like. And we're going to see a few more factory methods in later demos, but this one shows you just the basic nuts and bolts of what those actually are. The next pattern I want to talk about is an abstract factory pattern. Now, an abstract factory pattern is a creational pattern that provides an interface for creating objects without actually defining the concrete classes that use it. Now, in other words, this is just plain speaking an interface. But what it does is it defines the factory methods that would show up inside of what the concrete implementation of that, which would actually be a factory class or a factory object. Now, the abstract factory is useful when you have an application with a platform-specific configuration and needs objects pertinent to that configuration. Suppose I am writing an application for a Macintosh and one for a Windows PC. Well, in that case, I need the UI components for the Macintosh and I need UI components for the Windows PC. Well, in one instance, the code that generates the Windows components is not going to be the same as the code that generates the Macintosh components. So, but I want to have a standard interface. So what I do is I declare an abstract factory interface that has methods like get button, get window, get text box, get form elements, and then each implementation of that particular abstract factory, one would be for Windows, one would be for Mac. Well, in my code at runtime, I can select one of those two factories depending on what configuration I'm running, and then call the factory method to get back the objects that are coming back for each particular platform. Another instance would be when a user selects options from a particular family of objects, the factory can create objects in that family. So suppose I was wanting to create an application that had a particular kind of object, such as Chevrolets or Fords. Those would be families of objects. Now, I want to select a particular brand of car, and so what I might be doing is I would select, hey, I want the Ford factory, I want the Chevy factory, or I want the Dodge factory, and then in that I might have get pickup, get car, get sports car, or something like that, and it would return me a particular instance of that particular object. And then actually in my demo, I'm going to be demonstrating the second option that has a factory where I can select a family of objects and get back objects that relate to that family of objects, and I'm going to be using again that vehicle class that we saw just a minute ago. As I said just a second ago, we're going to look at an instance of an abstract factory where I actually select the factory, and then inside that factory I'm going to have methods to actually generate a particular kind of object that relates to a particular family of objects, in this case vehicles and makes of those vehicles. So let's switch over to the code and see what that code would actually look like inside of PHP. Now I've got my abstract factory example pulled up here. Notice what I'm doing here. I've got that same class I had a minute ago, the vehicle class. I've got your make and model. I've got the constructor and the display method here. Notice I removed the factory methods out of this, and I have this down here as an instance of truck, and it extends the vehicle class, and it just adds a additional property of what kind of truck am I dealing with, or what type of truck. And so it's inheriting from the generic vehicle class. And then down here, this is where the pattern actually starts. And this is my interface. Now in this interface, I declare I want two factory methods, and one is create car and one is create truck. Okay, and this is my actual abstract factory at this point. This is the actual pattern itself. Now down here is where I actually implement this pattern. I have the iVehicle factory implemented as a Ford factory and as a Chevy factory. And inside of those, I implement the methods that the interface declared of a create car and a create truck. And then here I get create car and create truck as well. But in this case, I'm returning a new vehicle. For a Ford, I'm returning a 2013 Ford Mustang, and for a truck, I'm returning a 2013 Ford F-150 4x4. Okay, down here for Chevy, I'm returning a 2013 Chevy Corvette, and then for the truck, I'm returning a 2013 Chevy Silverado half-ton. So I have two different methods, two implementations of that particular abstract factory. Let's flip over to the code and flip over to Chrome and see what this actually looks like when I run it. So let's pull up abstract factory method. Okay, again, this looks very familiar to the same UI. Select the make, I'm going to select Ford, hit go, and then it created those two instances I called the factory methods and got back a Ford Mustang and then a Ford truck. And then for the Chevy, same thing. I'm just getting back a Corvette and a Chevy Silverado. That's what we would expect from this particular program. So it's very simple, but you can kind of see how the abstract factory works. I have a family of objects, in this case a Ford family, and in another case I have a Chevy family, and I'm creating instances by calling generic methods create car, but I'm getting a car that relates to that particular family of objects. So that's what we're talking about when we actually use an abstract factory for creating families of objects. Now, if I was doing this for, like I said, configuration issues, the family of objects would be Windows components or Macintosh components or Linux components, whatever the platform may be that you're actually running your software on. The third pattern I want to talk about that's a creational pattern is a pattern called the builder pattern. Now what this does is provides a means to create complex objects. By complex I'm talking about objects that have a number of properties on them. Now what the builder is useful for is when the object has a number of properties that need to be set. And using the builder helps mitigate the number of constructors needed to create a concrete class. So imagine if you had an object that had 10 properties that you needed to set, but say 7 of them were optional properties. And you wanted to have a constructor for every possible permutation of that, well, you'd end up with just a ginormous exponential number of constructors on that particular object. Well, what the builder pattern does is it actually has 3 components that work together to kind of help mitigate all those constructors. What you have is a builder, a director, and then a concrete class. What the builder does, the director tells the builders what properties to set, then the director will instruct the builder to actually return the resulting object. So the director will say I was building a house, I'd say, add the floor, set the wallpaper to, green, and set the, outside to siding, and put in a, nice sidewalk, and then say build house, and then the builder would actually go about building it with those various specifications. So that's kind of the idea behind the builder pattern. In my builder demo, I'm essentially going to do what I talked about, except I'm going to use a car instead of talking about a house. I'm actually going to have a car vehicle again, and what I'm going to do is I'm going to take that vehicle class that we've seen already and then have a vehicle director and then a vehicle builder, and then see how these 3 different objects work together and to produce a particular concrete example of an object. Now my vehicle class really isn't that complex. It's only got 3 properties, so this might be a trivial use of the pattern, but in real life, if you had an object that had tons and tons of objects, hopefully you can see how this could be very useful when creating that style of object. Okay, now I've got my builder pattern pulled up here. I want to take a look at this code here. You can see I've got the same vehicle class I've been using for the last few demos. And now here's where the pattern really starts. I have these two abstract classes that declare a vehicle builder and a car director. Now the vehicle, and then you can put some additional stuff in this if you're actually building some more, real-world examples, if you will, of this. You might have some more code inside the vehicle builder in the abstract instance of that. But you might have more than one builder too as well, depending on the class. But in any case, you might have you need to declare at least one method in there that's an abstract method that looks like this, get vehicle. And then down here I have a car director, and in that car director I have a single method that I want it to declare, and that is the get car method. Now I could actually build another abstract class called a truck director, and it builds a truck instead. But in any case, these are factory methods that actually do stuff to get a particular instance of an object. And now down here, here's where I implement the concrete examples of these particular classes. I have my vehicle builder, and it's a car builder, and here I'm just setting various properties on a car. I'm just declaring a car object and setting it to null, all the properties to null to initialize it, and then storing that as a private variable until I get down here to the get vehicle method, and I can actually declare get back that private variable as the return on this particular method here. And that get vehicle is the actual factory method in this particular builder pattern here. So this builder class here. And down here I actually have two instances of directors. I have a Corvette director, and it implements the car director. And in the constructors, where I actually build the properties on the top of the class underneath, what I'm doing is I'm getting a generic car builder, and then setting the properties according to the Corvette builder, the Corvette director. Says to set it to a 2013 Chevy Corvette, and then the get car method down here actually calls the Corvette builder, which is a car builder, and then gets the vehicle and returns that as a concrete instance of that class. Same thing for for the Mustang director. The same thing happens. The only thing I did different here is I actually built a Mustang instead of a Chevy Corvette. I'm calling the same get vehicle method. But as you can see, like if I had a number of properties, it might look more like this, and I have just a lot of properties that I'm setting inside of this constructor here for an object that had a lot of different properties, and there might be some intelligence to these properties as well when I'm actually setting it. So you can imagine a class that has tons and tons of properties, that this builder pattern would actually be very useful for constructing that kind of object, rather than having a constructor for every known possible permutation of the various properties on that object. So down here, all I'm doing is getting out what make they select, and then just getting a different director, Mustang or Chevy director, and then just getting the car from that, and then displaying the car from the director. So it's a fairly simple pattern. Let's pull it up and see what it looks like when I run it, and you'll expect it just to print back a car. So let's go to builder, and I'm selecting a make, and I got back that 2013 Mustang, and let's pull this Chevy. I got back the 2013 Chevy Corvette. So it's using that builder pattern to construct the particular instance, directing the builder, and the builder sets the properties, and then it gets back the actual instance of the particular car constructed, and then returns that back to the calling class. So a fairly useful pattern for objects that have lots of properties and whatnot. So if you're doing with rather simple objects, this is probably not a very useful pattern. So it doesn't really show up that often, but whenever you see an object that has lots and lots of properties that could possibly produce lots and lots of constructors, think builder, and it's probably the case that builder is going to help you mitigate some of those constructors by simplifying the construction of objects using something like this. Another creational pattern that I think is very useful, and I've actually implemented this in a number of pieces of software I've written, is the prototype pattern. Now, the prototype pattern actually reduces the overhead of creating heavy objects. And what it does is it takes advantage of the sometimes more efficient cloning inside of a particular language than it does instantiating a new instance of an object for each use. So what you can do is you can take an object and partially load that object into memory, and then use the clone methods inside of many available inside of many languages to actually take that heavy object and then clone the properties into another object without actually having to use a lot of code that builds that heavy object. When I say heavy, I'm talking about something that takes a lot of effort to get that particular object off the ground. So you use a prototype, which is a partially populated object, clone its properties onto an instance of an object, and then you can actually return, maybe fill out a little bit more information on that object and then return it. So prototypes can be standalone, and they can be used both as a factory as well. But in most cases, the point of a prototype is that you have an instance of that particular class already in memory, and you're just going to clone it over and over and over again, because it's a lot more efficient to do that in many cases in many languages, and it also is a lot faster as well. In this example, what I'm going to do is I'm going to load up that same vehicle class I've been working with, but I'm going to have two different factory classes, one for Ford and one for Chevy. But I'm going to implement the prototype in each one of those, and then I'm going to use the PHP cloning capabilities inside of the PHP language to actually generate new instances of a particular vehicle from the particular prototype that I'm interested in getting, whether it be a Ford prototype or a Chevy prototype. Okay, here's the code for the prototype. You see here I've got that same vehicle class I've been working with. Here I declared the interface for the factory. Now the factory doesn't have to have an interface if you're just dealing with a particular instance of a class and you just want to clone it, but I have two different kinds of factories here, a Ford factory and a Chevy factory, so I declared an interface that has a make vehicle factory method in it. And so you can see down here inside of each one of these factories, I'm actually creating a prototype when the actual factory is constructed. So whenever I call the constructor, this is when I actually call the Ford, create a Ford prototype calling a new vehicle class. I'm actually just creating that class using the vehicle's default constructor when I'm passing in 2013 Ford Mustang, and then assigning that to a private variable here. Now notice what I'm doing down here inside of the make vehicle class, or sorry, make vehicle method. I'm doing it using return clone this dot Ford prototype, and that is actually using the clone directive inside of PHP to create a cloned version of this Ford prototype class here. And so this can sometimes in many languages is actually faster than instantiating a new instance of the class. Now obviously this is going to have the property set to 2013 Ford Mustang, and you can modify this later if you want to. But if you have a particularly heavy object where you have a lot of properties that are already set, and they're going to be shared among multiple different classes, and the properties are the same across multiple instances of the same kind of class, then this prototype can actually be very helpful for creating that kind of class as well. So I'm doing the same thing down here with the Chevy factory as well. So let's flip over to Chrome, and let's see what this looks like. Let's see, prototype. There it is. And you can see I'm selecting Ford or Chevy. So this should give me back a Ford Mustang, and then this should give me back a Chevy Corvette. And so you can see that exactly what it's doing was it's just creating a clone of that prototype. Now if I was to do this over and over again, you'd see a performance boost inside of the application, but since I'm only creating one instance, you're not going to really see a performance boost here. But the idea is that if you're creating an instance over and over and over the same kind of thing of a particularly heavy class, then you'd want to do something like this. And I've used this pattern again and time and again, especially on objects where I'm loading a lot of data out of a database, and I don't want to have to go back to the database every time. I can just cache it in memory and then clone it out of that prototype object into another instance of the object and get a much better response time in my application doing so. The last creational pattern I want to talk about is the singleton pattern. Now this pattern is used to enforce the creation of a single instance of an object. Now this pattern is useful when you want to create a single instance of a particular piece of data, or a particular object that contains a single instance of a particular piece of data. For instance, like a database connection. If you wanted to create a database connection for an application and you don't want to have multiple database connections floating around inside your application, you just create a singleton, and that represents the single connection to that database that you're dealing with, and across the entire application you don't have to replicate that over and over and over again. Another instance might be something like a registry. A registry is very useful inside of an application for creating single instances of lists, single instance lists. So I create a singleton, and inside that singleton I declare some kind of list, such as an associative array, which is in a key value pair. So because the key value pair is in a singleton object, I'm only going to have one instance of that key value pair available across my entire application because of the singleton. And so that's useful if I'm dealing with something like, say, currency objects. I don't want to create, several instances of the US dollar object or something like that. I can just create one instance and have that inside of a singleton, and it works like a registry in that regard. So the driver behind this is single instance data. Now, people sometimes create singletons or misuse them in their applications for creating things like management objects, or God objects that they don't want to create over and over and over again, that have access to everything under the sun. That's probably an anti-pattern and probably a misuse of the singleton pattern. And because of that, the new singleton pattern has gotten a bad rap among many software developers, and they actually kind of despise it because of that. But there really is a good use for it, and that's single instance data. But don't be tempted just to use a singleton in any instance where you can possibly use it. If I had a golden hammer that I was going to use, this would be it, because I've abused it quite a bit in my programming experience as well. But you just have to think single instance data, that usually will correspond to singleton pattern, but it is tempting to use it in other instances as well. In my demo, what I'm going to do is I'm actually going to create a singleton factory, and what I'm going to do is I'm going to employ the singleton pattern with factory methods in order to create a factory class that's got two factory methods in it. And the reason I would want to do this is, in many cases, you only need one instance of a factory inside of an application to create multiple instances of objects. So this would be a good use of a singleton class, so you don't end up creating multiple instances of factory classes if indeed you're using factory classes instead of using static methods otherwise. Now I've got my demo pulled up here. You can see that I'm using that same vehicle class I've been using throughout all my creational pattern demos here, the same vehicle class. But down here I've got a class called Sports Car Factory. Now this is a factory class that I'm going to be using as a single instance of this particular factory. And you can see what I'm doing here to make this work, and this is pretty much the same way you do it in every other programming language, is to set the constructor to a private constructor so it can't be called from outside of this class. And then what you do is you create a static function that actually will create an instance of this particular class, but it's stored as a static variable, a private static variable within the class. So you see what I have here is I have a static variable called inst, and then I'm setting it to null, and then I'm checking to see if the inst is set to null. Then I'm just calling the sports car factory constructor, but it's private in this case, so it can only be called from within a method inside of this class. And then once I get that particular instance declared, then it's set for all instances across the board here. Okay, and so I don't have to reset that. I only have to create this instance once. That's how it ends up maintaining or enforcing the creation of only a single instance of this class. But to really get down and dirty, what I've done here is I've actually overridden the clone method and said, I don't want you to be able to clone this class. So there's kind of a sneaky way in PHP where you can work around the instantiation of it by cloning it. But I just said I don't even want you to clone it, so I override the clone method and say you can't instantiate this class either. But once I've got the singleton created, it will only return this single instance over and over and over again without actually recreating it. And so anything that's available inside of the single instance of this class will only be available once as well. So I've got a single instance of the sports car factory, and that's probably all I really need for an application is a single instance of a given factory. And then it's just got two different methods on it, the create Mustang and create Corvette method, and these are just factory methods that I can call inside of this class. So down here you can see I'm just creating two different cars using those getting the instance of that from the sports car factory class. I'm getting an instance of the class and then calling the factory methods inside of that particular factory, and then I'm just displaying the properties of that those cars it created. So let's flip over here to the singleton. You can see I already got pulled up and load that up, and you see that I've got car 1 2013 Ford Mustang and car 2 2013 Corvette, and that's what we expect from it. And to show you that I'm only creating that once, let me go ahead and insert something into the code here. It's echo created. Sorry, oops. I'm going to say echo created once, and that should show up as only once if I truly created only a single instance of this class. And see, you see I only created one instance of that class, even though I got two instances of it on two different occasions inside of my application. So this verifies that the singleton is indeed working as we would expect it to. Now that I've talked about creational patterns for a while, I want to shift gears and start talking about structural patterns. My creational patterns have kind of been textbook examples of how you'd go about using creational patterns, and that's kind of been on purpose because your creational patterns are about creating objects. You're not really doing much more than that whenever you're dealing with creational patterns, so that it's kind of trivial to have those as when you're building standalone examples of those. You really don't do any more than just create objects. But when we start dealing with structural patterns, we actually get to see a little bit more real-world stuff going on inside of some of these structural patterns, and you'll see that as we work through some of these demos. The first structural pattern I want to talk about is known as the adapter pattern, or in some instances is called the wrapper pattern. And this is essentially allows two different incompatible interfaces to work together. So suppose I had an old legacy system that I wanted to adapt to a more modern system. So what I would do is I would take that legacy system and I would implement its API in a class, but what I would do is I would take that old API and expose it in a manner that could be consumed by a newer API, by a newer set of classes that were expecting a newer set of commands, but the legacy system will still do a lot of the work, but the current software that I'm writing for is expecting a different interface, so I can actually make that incompatible interface work with newer software by using an adapter pattern or a wrapper pattern. So it's just a way of making kind of equalizing or normalizing things so that you can use different kinds of objects, although they might be incompatible. In one instance, you can make them compatible by using them. In another instance, it's very similar to what you would use an adapter for in real life. If I had if I was traveling, oftentimes I travel with adapters so that I can plug my laptop into an outlet in Europe that I wouldn't be able to use my standard American outlet adapter inside. I would have to put an adapter on the end of it, then plug that adapter into the wall so I could actually use my laptop in, say, somewhere like the UK or somewhere like China. Without that adapter, I wouldn't be able to do that. So that's kind of where it gets the idea from. In my adapter example, what I'm going to do is I'm going to show you that I have two different kinds of objects. What I'm going to have is a gas vehicle, and I'm going to have an electric vehicle. Well, both a gas vehicle and an electric vehicle are still vehicles, but they don't work in the same fashion. One of them consumes gas, one of them consumes electricity, and they both you can drive both of them, but in one instance I have to put gas in it and it uses an internal combustion engine to get acceleration. One of them you have to put charge on the battery and it uses a electric motor to do the same thing, but nevertheless their application is still the same, but the terminology is slightly different, so my method names would be slightly different. So what I want to do is I want to build an adapter to make the electric vehicle behave like the gas vehicle so I can use them in the same kind of fashion, but I don't want to have to write two different programs to get the same kind of behavior, so I'm going to write an adapter for one to kind of normalize it so that I can get the same kind of behavior out of both vehicles. Now up here inside of my adapter class, I've declared an iGas vehicle interface. The reason I declared this vehicle interface is because this interface I abstracted from my gas vehicle so I could build something to kind of normalize this. So this is what you would do to actually make an adapter pattern. You first declare some kind of interface to kind of normalize it. My gas vehicle is my the instance I want to work with. I'm actually going to work with a gas vehicle here. And that's what I want to normalize the electric vehicle to be. So I abstract from this a gas interface, iGas vehicle interface, and the function that I want to abstract from that is the give it some gas function. So here I just create a gas vehicle, and I have several different speeds. I'm sorry, properties. Your make, model, and speed, and then my constructor just sets those, and then I have the display property that we saw from our other vehicle examples, and then to give it some gas function just increases the speed by 5. So down here in the electric vehicle though, I have this electric vehicle class. It's the same thing, same basic properties, everything's the same, and even the display is the same. The only thing I don't have that's different is instead of give it some gas, I've got to give it some volts to make it increase its speed. Because if an electric vehicle doesn't burn gas, it uses electrons and spinning magnets to increase its velocity. So I increase the voltage, and then I would increase the speed of the vehicle in doing so. But these two classes aren't compatible with one another because of this method here. So in order to make this work, I had to come down here and write a electric to gas vehicle adapter extends electric vehicle, but implements the iGas vehicle interface. And so this is just inherits everything from the electric vehicle, but then it declares this method here, give it some gas. Well, this is the adapter method, and all it does is calls the parent give it some volts method as well up here to increase its speed. So this adapter method here, adapter class, I actually wrap around this electric vehicle class and just expose an additional method to kind of normalize it so I can treat the gas vehicle and the electric vehicle the same. And see down here, I'm just declaring two different new vehicles here. Electric to gas vehicle adapter, and then I'm using the looping over it, give it some gas, calling the same method on both of those, and to increase its acceleration over and over and over again. So let's flip over to Chrome and see what this actually looks like. So let's go to adapter.php, and you can see I'm just displaying the display here. You know, car 1 is a 2013 Tesla Roadster, which is a really cool electric vehicle, and I'm accelerating it, and I have a Ford Mustang and accelerating it as well. So that's kind of how you would see the adapter pattern played out, is when you actually adapt those methods and whatnot. Like I said, very useful for wrapping up legacy APIs and exposing them in new manners that can be consumed by more modern systems like PHP if you were adapting some kind of old SOAP RPC or something like that. The next pattern I want to talk about is the bridge pattern, and the talking about it as a structural pattern. Now, the first time I looked at this pattern, whenever I was doing object-oriented programming, I didn't really understand what it was talking about because it had a rather vague definition, and this definition seems to be quoted everywhere because no one can seem to come up with a good definition for the bridge pattern. It's kind of one of those things that's better seen than explained, and you'll see why when I actually start digging around in this. But the textbook definition of this is to decouple abstraction and implementation so that they can vary independently. That basically translates into you have objects, and then you have the code that actually uses that objects. The objects being the abstraction, so I have different ways of abstracting data out of different forms. Suppose if I was working with different document formats, I was working with Word, WordPerfect, OpenOffice, and then HTML. Those are my abstractions. I abstract that into a single document, but I want to display it in another form. Well, that's the actual implementation of that object. So I want to display the object as just a read-only type view for printing, or I actually want to display it in an editor. Well, either case, I have to I have the abstraction, which would be loading that object out of the file into an abstraction, which would be an object that's in memory, and then I implement that as either a display for printing or an editor for editing or something like that. So that is what the bridge pattern is really trying to accomplish. And so so these two can actually vary independently. So you don't have to have a load Word document into editor method. You can load the Word document and then take that generic object and load it into the editor once you have it loaded. That's basically what the bridge pattern is trying to do. And like I've said, it's often used where data is stored in multiple formats and presented in multiple media, and then it's effectively to normalize the data so you're not going to couple your implementation to a particular data format. And I'm going to do just that in my demo, and this is actually a fairly good demo, I think, for demonstrating that, and you'll see why in just a second. In my bridge pattern demo, what I'm going to do is I'm going to load data from a weather service, but I'm going to do it in two different formats. I'm going to use JSON, I'm going to use XML. And what I'm going to do is I'm going to abstract that data, and so that would be my abstraction. And then what I'm going to do is I'm going to abstract that data into a single object, and then I'm going to implement that object as two different displays. One is going to be just a sentence to describe the weather, and another one is going to be like a little weather widget that you could display on a page. So I have two different implementations and two different sources of data. So I have an abstraction and then two different implementations of that abstraction. So they can kind of fulfill that textbook definition of abstraction and implementation varying independent of one another. So this is, like I said, one of those things that's better seen than explained. So let's flip over to the actual code and see what this looks like. The first thing I'm doing on my bridge pattern here is I'm actually declaring I want my two different abstractions. I noticed I have the abstract object, and then I have the implementation of that object. The actual implementation is the displaying of that object. The abstraction is this abstract class, which I just call weather. Okay, and when I construct any one of these weather objects, what I'm going to be passing into it is an instance of the iWeather display, concrete instance of an iWeather display interface. And so that's what this is going to be set to, this display property. And once I've got this concrete implementation of the weather object implemented, I'm actually going to call the display method on this get display method up here on this interface inside of my concrete example in order to display the actual weather in whatever display class according to the display class. So that happens down here in this show weather function. I called this .display.getDisplay, and then I pass in this, which would be reference to the class. So this abstract class here, though, is the abstraction that I was talking about. Notice, remember I talked about abstractions and implementations of those abstractions. The first thing I'm doing is declaring an abstract class, and anything that is derived from this class will inherit all these properties as well. So the high temp, low temp, condition, icon, these kinds of things here. And these are just some parameters that are used across the implementations. And the show weather function is also shared across these implementations as well. But the one thing to make this work, I declare an abstract public function called load weather. That means I want the actual concrete implementations to actually implement this particular method in order for it to be an instance of this particular abstract class. So what I did is I created two concrete instances of that abstract class. Notice I have XML extends weather, and all this does is loads from a weather service. It loads XML data and then loads into that XML data, from that XML data, the properties out of that XML data into my abstract class. And these properties, high, low temp, condition, and icon. And I'm using curl and then the simple XML API inside of PHP to do that. Down here in the JSON weather implementation, I'm doing something very similar, except I'm using the JSON format. I'm using curl to get the data, and then I'm using the JSON API available inside of PHP to load those results. And then down here I'm actually loading the data out of the JSON parsing and then into my abstraction, which would be my weather object. And then once I've got that loaded, what I can do is I can pass into any one of those objects I can pass in a display class or a display object that will actually format the abstract data in a particular form. So this would be my actual implementation, while the XML weather and the JSON weather are the abstract, are the concrete examples of the abstraction that these display classes can actually be are the implementations of these that vary independently of the actual abstract the abstraction, which would be that weather class above. So I have the weather class, which is the abstraction, and then I have the implementation of the weather class, which is the display. And this is a classic example of how to do that, except I'm using more modern technologies such as web services and HTML and what have you. And so this is just spitting back those one as a sentence and one of them as something like a widget display on the screen as well. And so, and down here, I'm just creating a couple instances. I'm setting the queue to default to be Atlanta, and then I'm saying widget using a show widget, and then a show sentence as my different displays, and then I'm passing one of those into the JSON weather, and then using that JSON weather as a sentence display, JSON weather as a widget display, and then I'm using the same thing here as the XML as a sentence display, using XML as a widget display as well. So you can kind of see how I'm using the XML widget with both displays, and I'm using the using the XML weather with both display types, and then I'm using the JSON weather with both display types at the same time. So the bridge pattern is a little complex, but it's actually a highly useful pattern, especially when you have data that can come in multiple formats, and you can represent that data in multiple formats as well. It's a very useful pattern for that. Now that we walk through the code, let's pull this up in Chrome and see what it looks like. I'll switch over to the bridge pattern, bridge.php, there it is, and let's pull this up. So you can see here I have the JSON sentence display, and I'm just displaying it as a sentence. I have the JSON widget display, getting the same data out of the XML data, XML sentence display, and the XML widget display as well. So you can see how I'm using two different implementations, but I'm also using two different abstractions as well, and to get the same kind of behavior. So I have abstraction varying from implementation, and this is how you go about doing it using the bridge pattern. So it's a very useful pattern, like I said, if you have data formats that exist in different contexts, and implementations or displays in different contexts as well. The next structural pattern I want to talk about is the composite pattern. Now this pattern is used to allow groups of objects to be treated as the same way as a single instance of an object. Effectively, with a composite pattern, what you have is a tree-like structure, and the tree-like structure has composite objects which have one or more or zero or more other objects attached to it, and then leaf objects, which are just single instances of a particular object. Now, the composite object might have additional composite objects or leaf objects, so you can have either one show up inside of that particular group. But in any case, the composite object, the composite object and the leaf objects will have a set of shared properties that allow them to be treated the same way. One classic example of this is the document object model. If you're familiar with the document object model and how it works, you know that it has leaf nodes such as image tags, for instance, and it might have container nodes that such as divs. So you might have a div that has several images in it. Well, the images would be the leaf nodes, and the images would be the leaf nodes, and the div would be the parent node, or would be the composite object in that instance. So you have the composite pattern employed in the document object as well. So you can see how you have the ability to treat the composite objects and the leaf objects as if they were the same object. The only difference is one has multiple instances of it. And this pattern is very useful, especially when you have tree structures where the tree structure is arbitrarily deep, and you don't really distinguish between the composite objects or the leaf objects. I found myself using this pattern over and over again in multiple applications that I've written over the years, not even knowing that I was actually using it until one day someone told me, hey, that's a composite pattern. I said, oh really? I was like, I've been using this for years. It's just seemed natural. But you can see how it can be used in many other instances, as well as the document object model and whatnot. Next, I want to talk about the iterator pattern. Now, this is a behavioral pattern, not a structural pattern. The reason I want to talk about it now is because the iterator pattern is used heavily with the composite pattern and in fact, it's used so much nowadays that many languages have built-in support for iterators right out of the box. You don't have to build special, special classes for iterators. Most of them have it built right into the languages, and they even have special language level directives such as for each loops that show up in the language that work with iterators behind the scenes. Now, what the purpose of iterators is for is to separate algorithms from containers. Now, the containers would be something like a composite object where you have, a container where you have multiple, sub-objects inside of that container object. Or in the case of a composite object, you have a tree. If in a list you have just a straight list of objects, or arrays, you just have, straight lists of objects there as well. So various container objects such as arrays, lists, and tree-like structures, you might want to separate the algorithms that manage that, so the iterator pattern actually provides a nice way to do that. And so you implement an iterator, and then you can loop over that, use that algorithm inside of that iterator pattern for each of the objects inside of that particular container. So the iterator pattern inside of PHP actually has a special interface that you can actually build iterators from, and you can build these customized iterators that are beyond the basic ones that are provided by the provided for arrays inside of PHP. So, and I'm actually going to use this because I'm going to build a composite pattern using a composite pattern, and then I'm going to build a customized iterator so that PHP can loop over that composite pattern using a for each loop inside of the PHP language. And as I mentioned already, composite patterns are used heavily with iterator patterns. In my next demo, what I'm going to do is I'm going to create a composite object, but this composite object is just going to go out and get data off the file system. Now, a file system obviously has a composite object, which would be a folder, and then I have a leaf object, which would actually be a file. And what I'm going to do is I'm going to take that, you treat the folder as a composite object, and I'm going to treat the file as my leaf object, and then create a hierarchical structure using the file system on my computer. And then what I'm going to do is I'm going to build a custom iterator to aid in looping over that composite object, and then I'm going to use a for each loop inside of PHP to actually loop over that object and show you what it looks like. That's how I can build customized iterators in PHP and composite objects from different things on what have you. Now, the first thing I've done in my composite iterator demo here is I've declared a abstract class called a file system object. Now, and this is actually a component of the composite object. So what's going to extend this is actually the folder object and the file object. And I have two properties in this, the name and the parent, and those will be inherited by the file and the folder objects down below. And I have just a simple function get path here. And what this function is just a utility function to get the path of this particular folder or file, whatever it may be. And then down here I have the actual, here's my leaf node or my leaf object, and this is a file object, and I have just one additional property here, and it's the actual MIME type of this particular file. And a folder doesn't have a MIME type, it's just a folder, but a particular file does. So it does vary a little bit in that respect, but it can be treated the same as a composite object, which would actually be my folder down below here. In my folder, I just have a public property, call it files, and it probably should be files and folders, but this is where I'm actually going to store any kind of files or other folders that exist inside, subfolders that exist inside of the folder that I'm representing with this object. And then I have a few different methods here for adding and removing different objects from this. So this is a fairly simple implementation of a composite, but so I can have different folders that contain folders, or folders that contain files and folders, so I can end up with a tree-like structure that's arbitrarily deep and arbitrarily long and what have you. So this is the one instance of how you might actually go about building composite, and I have just utility methods for adding and removing files from that. Now down here I have the actual iterator that implements the iterator interface inside of PHP. So I call this a file system iterator. And the constructor on this, I pass in a root folder object, which would be an instance of the folder object that we just saw up above. And this iterator pattern just has two private variables, files and positions inside of that. Now this private function here, what I'm doing is I'm just recursively calling this to kind of build a linear representation of this the file structure here, and I'm just taking that folder that's passed in and just building a linear representation of it rather than having all of those files in all their subfolders. I'm just creating like essentially a stack of those folders in the order in which they came in the folder, and then putting those on top of this file here, so when I actually iterate over it, it makes iteration rather simple. And then these are the methods that the iterator requires that I have: rewind, which sets it back to position 0, current key, and I'm just returning the stop position, which is the number, next, which increments the position by 1, and then valid, and then that just returns if is set this position or not. So those are the methods that are required by the iterator interface inside of PHP. So let's go down here and see what the implementation of this actually might look like. Here, this is a function that actually go out and look at the file system using the PHP file objects, and then I'm just going through and building out that a folder here. So I'm not going to get into the depth on that code. It's just building that file hierarchy inside of an object representation of that. So here I'm going out and getting that, calling that utility method I just showed you with this root folder here, which is the htdocs root folder under my XAMPP install on my local box here. And if you're dealing with another box and you're working with this, you just change this folder, and you can work with any folder so long as PHP can read it. And then from there, what I'm doing is I'm creating that folder, getting the files out of that folder, creating a new iterator here, and then I'm just looping over this using a for each loop. Here, my file system object iterator as an htdoc file system object, and then I'm just echoing back the path of that using that utility method up inside of the abstract class. And then if it's a folder, I'm just spitting out, it's a folder. If it's an if it's a file object, I'm spitting out its MIME type. So it's a fairly straightforward demo, but it shows you how you might build a composite, an iterator, and then how you can use that iterator in PHP inside of a for each loop in the PHP language, because iterators nowadays are built into most object-oriented languages anyway. So let's flip over to Chrome and load this up, and let's pull up my gang of 4 demos here, and I think I called that composite and iterator, and there it is. Let's give this a second to load my file system object, and you can see here that it's just pulling back all of the files I have inside of my htdocs folder. Now there's a bunch of them in there, and I got PHP folders, graphics folders, different things, text files, XML files, what have you. So you can see how that's working, and this is what it's actually displaying on the back side of that. So that's how you might go about building an iterator and building a composite object inside of PHP. The next pattern I want to talk about is a structural pattern called the decorator pattern. It's kind of a structural pattern, but it's also a behavior pattern and kind of two, because what it does is it creates a chain of objects that allows you to have one object but add additional behavior to that object by essentially decorating it with another decorator object. So you start with a base object and you add a decorator object to that base object, and then you can tack another decorator onto the end of the chain and yet another one. So it allows you to have dynamic behavior inside of a set of objects, and you can choose these at runtime depending on what options are selected, and then depending on how you build that chain of objects. So it's a very useful pattern if you need dynamic behavior, and so you can actually isolate that behavior and encapsulate that into essentially decorator objects that you can tack on to additional objects as well. But this is again one of those patterns that I think is better seen than explained. So let's do a demo of this and see how this might actually work. Now, my decorator demo, what I'm going to do is I'm going to simulate a pizza restaurant or something like that. What I'm going to do is I'm going to have a pizza, and what I'm going to do is I'm going to allow the user to select different toppings to put on the pizza. And in doing so, what you're going to do is you're going to start with a base pizza, and then you're going to decorate that pizza with decorator objects, whether that be a cheese object, a topping like a veggie object, or a meat object or something like that. So you have these various ingredients that you would put on the pizza, as well as the different prices that are attached to one of those ingredients. So as I build out the pizza, I can dynamically create a pizza that has different behaviors. So yeah, I just want veggies and I don't want meat, or I just want cheese and don't want veggies. I can add different ingredients to the pizza and get a dynamic behavior from that decorator, from the decorator objects, and get dynamic pricing and whatnot using the decorator pattern. Now, most decorator patterns are going to look something like this one here. What I'm going to start with is an abstract class. This is kind of the base of everything that's going to go on inside of this decorator pattern. And so I have this abstract class called pizza, and I have a protected property called price, and then I have two functions called getPrice and getIngredients. But I declare these as abstract functions because I want every class that implements this or extends this to declare these various functions here. So next thing I do is I declare a base class, and this is the base class that's going to be decorated by my decorator classes, and in this instance I call it base pizza. And so what I do is I declare I declare the base price to be $5, and then I have the two various functions, get price and then get ingredients, and that's my base pizza. So that's just the bare minimum, pizza with sauce on it, and nothing else, I guess. Then I come down here and I declare a pizza decorator class that extends pizza. Now this abstract class extends the base class of pizza, but all my decorators are going to end up implementing this, or extending this decorator. So it is actually, everything is building on top of that original pizza abstract class as well. In this case though, I have a pizza object that I'm passing into it, and then this ends up being what everything gets chained to. So I mean, if I pass in the base pizza to this, and then I chain the decorator to this, and then I would take this decorator, whatever this gives me back, and I would chain to that the next chain to this decorator the next decorator as well. And you'll see how I'm doing this below whenever we look at some of the implemented code. And so here's those two methods, get price and get ingredients. So I'm just calling the base class here get price and get ingredients as well. But as I start to implement this particular decorator, you see here is I have a implementation of that crust, and then I'm passing into that pizza and crust. That pizza is the one I'm going to chain this decorator to, and then the crust is the whatever crust the user selected, and then I'm saying that I'm incrementing the price depending on the crust they select. So if they crispy crust, well, every crust, I don't care what it is, I'm just incrementing the price by 2. And then you see down here I've got a same story for cheese, for meat, and for veggies. And so I have a meat, veggie, cheese, and crust decorator, 4 different decorators that I can tack on to this pizza. And down here inside of my code, I have a form that I'm basically allowing the user to select crust, cheese, meat, and veggies, and it's just a bunch of check boxes that they can select. And then what I'm doing here is up here inside of this PHP block here, as I'm declaring a base pizza, I'm getting the crust, that I'm setting the pizza variable to that crust because I'm chaining the crust to that pizza, and then I'm getting whatever kind of crust they selected from the form. And then again I'm doing that for cheese, and then I'm chaining the cheese to the crust variable, and then for each of the meats they selected I'm doing a loop over the meats, and building the pizza with the meat, building the pizza with the meat, and then keep on chaining those decorators to the pizza object, and doing the same with veggies here. And then last but not least, I'm getting the ingredients here. Now what I'm doing here is I'm actually just replacing the last comma with and. Whenever I get the ingredients, I'm getting a variable down here and calling my pizza.get ingredients, but instead of having a comma, I'm replacing with and, so it's more grammatically correct. And so I'm saying ingredients, printing that back to the user, and then I'm saying getting the price and then displaying that back to the user as well. Okay, now that you've seen the code, let's flip over to Chrome and see what this looks like. Let's pull up the decorator class here, or decorator demo. And you see here I have a little simple form for building a pizza. Say I want a hand tossed, I want Romano cheese, and let's put it on bacon, ham, and bell peppers, and order that. And so I have a hand tossed crust with Romano cheese, ham, bacon, and bell peppers, and the cost of that is $17. Let's go back and just, for grins, let's build the meat lover pizza. Let's put all the kind of meat on there and decorate with that. So I have a hand tossed crust with Romano cheese, pepperoni, ham, bacon, sausage, and ground beef. And the cost of that is $24. So here you can see how I'm dynamically adding behavior to the original pizza by tacking on various decorators to that pizza. So I can have dynamic behavior by selecting options from lists or whatever, and just tacking on that to the chain, and then just calling the chain to give me back to do all the operations or whatever it may be for this particular decorator pattern, whatever it may be. In this case, I'm using it to make pizza, which I think is making me kind of hungry at this point. But you can see how this would work for building an application for pizza, or you might want to do it for coffee, or you might want to do it for a salad or something like that. But it does have applications outside of the food arena as well. The next structural pattern I want to talk about is the facade pattern. Now this pattern is essentially used to mask complexity. Now when we say complexity, we're talking about a lot of different things here, but complexity can manifest itself in different ways. You have a complex API and it's got a lot of different methods, but you can encapsulate those methods into a single method that does a lot of operations on behalf of the client that's consuming a library. So it's often used to mask library APIs and things like that, so the dependencies are moved away from the client that is actually consuming them. You mask it in a facade pattern, simple as that. Another way to do the facade pattern is to implement it using simplify API access from complex APIs by providing a wrapper around that. So a facade can actually manifest itself as an actual wrapper. So you might have the facade manifest itself in different ways. One way I've used this over and over and over again is when I'm using it to implement encryption inside of an application. I want to encrypt files or something like that. Well, to do encryption, there's several steps that are involved. You have to get a hash algorithm, you have to get a vector, you have to get a hash, an encryption algorithm, and you have to get a key, and you have to do all these calculations in order to get that set up just so you can do the encryption. Well, I don't care about doing that every time I want to call the encryption algorithm. I just create a method that encapsulates all that, and then all the complexities that are necessary to implement that encryption are masked from the actual application that always wants to get back as an encrypted string or something like that. I just say, here, go encrypt this, and then I call the method encrypt. I pass it a single string, and it gives me back encrypted text. All the actual complexities of doing the encryption are buried inside of that facade pattern. So that's one instance. We're going to see another one inside of our demo. In the facade pattern, what I'm going to do for my demo here is I'm going to basically have a complex set of classes that simulate a car. Now I'm not going to simulate the entire car, but what I want to have is like a transmission, a differential, gas pedal, and whatnot, and then have all these components working together that actually simulates the inner workings of a car. Now as a mechanic, I would be interested in all that, but as a user of that vehicle, my concern isn't really so much about how it works. All I want to do is get in the car and drive it. I'm going to turn it on and go. Now a mechanic would be more interested in the entire inner workings, from the engine all the way back to the wheels and everything in between. But for a user like me who's not a mechanic, all I want to do is get in the car and drive it. So a facade pattern would be a way of masking the complexity of that car by just saying, having two methods, start and drive, while a mechanic would be more interested in the actual inner workings of how everything is going on inside of that car. So I'm essentially going to be masking the complexity of the car by having a facade pattern underneath the hood, no pun intended. Okay, now here's my actual demo. What I'm doing is I'm constructing a vehicle here. You can see my vehicle has several parts. I have an engine, a transmission, a differential, and wheels. Now, in the this is my actual facade class here. When I construct this, I have I'm just saying this.wheels differential engine, building the actual car here in the constructor, and then populating these various properties up here. But I just have two simple methods: start and drive. And what I'm doing here is I'm just starting the car, and then the drive is like engage the transmission, and then the transmission engages increase the throttle or something like that. So you can see that I'm masking some of the internal complexity of this vehicle by just having two simple methods and actually constructing it here. And then here's all the supporting classes that I'm using under under the hood, no pun intended, for the facade, the differential wheels and all that. So, and down here is where I actually call it. I say, get me Mustang equals new vehicle, Mustang start, Mustang drive. So this actually masks all the complexity and all those classes we just scrolled through just a second ago. So let's flip this up and then pull this up inside of Chrome and see what it actually does. I create the actual car and then we can call drive and see what happens when I do that. So in that case, I started the engine and I said drive, and drive says, well, okay, I'm engaging the transmission. I increase throttle, the transmission is turning, the differential is turning, and the rubber is burning. So I'm a poet and I didn't even know it. So there you have the facade pattern showing you how you can mask complexities of a lot of underlying objects by just using a simple facade and two very simple methods, but actually have a lot more complexity that's buried underneath that. So you can kind of separate out the dependencies. The facade needs to know about the dependencies, but the actual calling class does not. So that's one way of getting good decoupling in your application, is if you do a facade of sort. And I do this, like I said, with encryption all the time, because I don't want to put all that encryption stuff inside of my main program. I delegate that off to a facade class, and it does all my encryption for me. The flyweight pattern is a structural pattern that is aimed at minimizing resources used by sharing data between similar objects. And the flyweight pattern implements a factory class that has a caching mechanism such as an associative array in PHP to store instances of that object. And then what happens is in that factory class there is a factory method that accepts a parameter of a key, and if that key exists inside the cache, then it will return an instance of that object rather than instantiating that actual object. One classic example that this is used often in is something like a word processor, and instead of creating instances of the bitmaps necessary to create the characters on the screen, what they do is they end up caching the characters that you can type in, and then each time that character is accessed, it just goes to the flyweight pattern to the factory method to get say the E character that has all the instructions that are needed to draw the E on the screen, and it just stores that in memory. So every time you hit the E, it just gets that single instance rather than getting reinstantiating the E key every time it's mashed. So that way you minimize the amount of memory used in something like a word processor or something like that, and keep that memory footprint down. Now there's other uses for this as well, and the demo I'm going to end up using a caching mechanism, and you'll see how I use it. Using it a little different, but yeah, the idea is the same, so I don't end up recreating objects over and over again. Rather, I just keep those in memory and then keep the resources I'm using down to a minimum if possible. In my demo for the flyweight pattern, what I'm going to create is a direction application. It gives me directions, either walking directions or driving directions, and what I'm going to use as a data provider for this is Google's direction service as part of their map API. And what I can do is I can pass it in some parameters and get directions back from that service. But instead of calling the service every time I want to get directions, what I'm going to do is I'm going to cache the directions in memory on my machine here. That way I have those in memory, and I can alias those directions using a key inside of an associative array. And once I have those directions, if the user asks for them again, I can actually pull those out of cache rather than going off to Google and recreating that object every single time. And the byproduct of this, kind of a free byproduct of this, is like if I have a cached offline cache directions on at my application, I could in theory take this offline, and then I wouldn't need to be connected to the internet to have my directions available in my application. So this might be an instance where you could actually use something like a flyweight as a caching mechanism, as well as a way to cut down on resources, time and memory, by calling the same service over and over again, rather just keep that cached instance local and not have to worry about going out there and getting it every single time the user asks for it. Okay, now I've got my flyweight demo pulled up here. You notice I'm using sessions here. And the reason I'm using sessions is because I'm going to be doing some caching in this, and what I don't want to do is throw away my object cache that I'm going to be using in my flyweight pattern every time I run the script. So actually I want to keep this alive, so every time I reload the script, I'm just going to load that out of the session, and that way that it's a little bit less burdensome than actually going out to the Google service and getting that information every time. I can load it off the hard drive, and it's conveniently in memory, so I still not truly caching it in memory constantly, but it's a little bit better than going out to the service every time I want to get an instance of one of my objects that I'm actually going to be caching. So that's how you might go about accomplishing keeping the cache around inside of a scripting language such as PHP. You can see here that I have an abstract class called route. Now this is the abstract class of the concrete objects in which my factories are going to be creating. So I have a route object, and I want my route factories to create these route objects. And you can see I've just declared a couple of properties here, directions and names, and then I'm calling a constructor, and that gives it a name, and then the directions is just an array, and that's just a string, list of strings that kind of represent the directions on how to get from point A to point B for whatever route that I'm loading up out of Google services. And then this function here, add segment, is just a simple function to instantiate something inside of that directions array there. And then this last abstract function here is get directions HTML. This is what I want to implement for inside of my concrete examples of this, and you'll see that in just a second down here. So down here inside of my driving directions, I have the get directions.html, and then I have, what I'm doing here is I'm just printing out the directions as a list, essentially, not using an unordered list or anything. I'm just printing divs with the instructions there. But the only difference between this and the other driving direction and the walking directions is that I print walking directions instead of driving directions. So this is kind of a trivial difference between my two instances of my concrete, my two concrete classes, and driving directions below, but it kind of illustrates how you could have two different concrete methods using the same abstract class up here. And this one I'm doing the same thing. The only difference is I'm declaring walking directions down here. And that's so that I can have two different objects that are returned by my factory. So here's where the actual pattern begins, really, is in this route factory here. Now this route factory has this cache here, and this cache here is, I call it routes, and then that is just declared as an array whenever I call the constructor. And then I have two factory methods, make walking route, and then the last one down here, make driving route. And then what I'm doing here is saying if the name of that route exists, I'm returning it from the routes cache. So I'm assuming that if they call that same thing, the name of the route, the same name as something else, instead of actually loading that out of Google services, I'm actually going to load that out of my cache, and then it'll return it much more quickly, and I don't have to spend the resources to actually create that route in memory. Otherwise, I go through the process of creating that using the route API inside of Google Maps, and then I get a new walking route and I add that to the routes list there. Same thing down here for driving directions, and the only difference here is I've got I'm creating a driving directions instead of walking directions, and it calls the exact same service, The only difference is I'd say the mode to driving, so that's really the only difference between those two. I just did that so I could have two factory methods, but really you could combine those and make a single method if you're making probably a more quote-unquote real-world example. And then down here I just have two utility methods to give me back a route name if I want to get it by name only, if I know it's in the cache already. And then I have another one down here that says just gives me a list of all the routes. And that's how the pattern would look if I was actually using it. And then, so what I'm going to do is I'm going to flip over to Chrome, and let's pull this up inside of Chrome. So I've got my facade loaded. Let's load up flyweight.php. And you notice here I've got what I was using that get routes for so I could populate this drop down. Notice I don't have any, so I need to create a new route. Let's say I'm going to, home to work, and let's say I live in my old hometown is Carrollton, Georgia, and my destination is Atlanta, and this is driving, so I want to create my commuting route every day for my commute. So I'm going to create that route, and here I'm printing out the actual day call up here, and notice that here I have my route home to work, and that's what I've been calling it, and that's my route name. And so if I want to reload that, I can just go get route, and it just loads it out of the cache and whatnot based on the key. But if I want to create a new one, let's go work to home. I guess I already created these at one point, and I'm going from Atlanta to Carrollton, Georgia, and this is driving directions. Let's create a new route for that, and I should have the reverse of that, work to home, and get the route. It's returning the exact same thing, but it's doing it much faster because it's loading it out of the cache versus loading it from scratch every single time. So this actually saves me time and effort rather than going out to Google services and using all the heavy lifting that is needed for that, loading up curl and then loading up the JSON parser and doing all that. I just go to my cache, get it from there, and it's much simpler and uses less resources. And I don't have to worry about doing all that heavy lifting. And so this implementation of the flyweight makes a very fast and agile application by implementing a caching mechanism for implementing shared resources. So if every time I call this, I don't have to go out there and load it from scratch. So that's one instance of how you could use the flyweight pattern. One of my favorite patterns is the proxy pattern here, and proxy patterns are very common in many distributed systems, and the reason why is because proxy patterns hold the place of another object, and typically in distributed systems what you end up having is you have the object originating on a remote system, and it's being passed across a network, then it's being received by a client and in a serialized form, and then it's deserialized into an actual concrete instance of that object. But in the meantime, before that actually all happens, you have something that stands in the place of that object on the receiving side, and that's where the proxy pattern comes in. And you'll see the proxy pattern employed quite often if you ever use web services and you use some kind of automatic code generation to build the APIs that are going to be build the APIs on the client side that consume that web service that's being served up by a server on a remote server somewhere. It actually build a bunch of proxy classes in that service, and that's one way to implement a proxy pattern. But the idea is that you have a lightweight instance of that proxy that holds the place of a more heavyweight on the back end that needs to be instantiated later on. That's what we call late initialization, which is typically what happens in web service APIs and whatnot. Or in some instances, you might want to put a proxy pattern in a proxy in the place of something, and then pass the initialization of an object to a background thread, and then let the background thread actually load that object up later on in the background while your main thread continues working on the application, because sometimes heavy objects take a long time to load. So you can still have access to that object even though it's not fully loaded until the initialization of that object is done. And another reason to have a proxy pattern is to hide complexity similar to a facade pattern. So if you proxied a complex API with just a simple proxy object and it held the place of a large object behind the scenes, you could actually simplify the API inside of the consumer and then have something behind it. But by and large, the proxy pattern is very useful, particularly with distributed systems and web services and for loading heavy objects. That's what I've mostly used it for, is whenever you're doing late initialization such as loading up something from a web service, and you still want to have a responsive application, but you still want to have something available, but you haven't actually got the object back from the API yet either, which sometimes in some instances can take quite a while if the API is slow, or you got a slow internet connection or something like that. In the proxy demo here, I got a little carried away because I just had way too much fun writing this demo. What I did is I wrote the game Blackjack, but in the game, what I'm doing is I'm using objects to represent, the cards in the deck. And what I wanted to have graphics associated with this, but graphics are heavy objects, so rather than actually load the graphics when I load the card, what I did is I used a proxy pattern to actually load the proxy card into memory, but it still got some of the properties, but the actual heavy lift and the actual fully form card is loaded when I actually load the bitmap into memory. And then once the bitmap is actually loaded is when I'll actually cache that card using something similar to what you would do inside of a flyweight pattern. But the idea is that you have that proxy pattern loaded. It's a lighter weight version, and then I do late initialization on the actual full-blown card, which has the bitmap image that I'm going to be sending back to the browser to display the card. So let's flip over the code and take a look at what's actually going on inside of the proxy pattern here. Okay, now I've got my proxy demo loaded up here. You can see that I've got an interface here, and this is my iCard interface, and this has got all the methods that I need to load up a card object here. Get suit, get value, get bitmap, get index, flip, and face down. Now the get bitmap is the one I was talking about, because whenever I'm loading the card, I don't really care about the bitmap per se until I actually send that back to the browser for displaying that. All I really care about for the game purposes is the suit and the value. And so really what I'm getting here is just the bitmap data here. And that's when I actually load up the actual concrete instance of the card. So keep that in the back of your mind as we look at some of this code again. I'm using a partial class here. Although PHP doesn't really have a concept of partial classes, you can kind of emulate that behavior using an abstract class in PHP. So this is what I call a partial card object, and it's got the index and the face up. And this is basically shared code between the proxy implementation of the card and the full-blown implementation of the card, which we'll see down later. And it's just returning the suit and then the value of the card, ace 1 through 9 or 1 through 10, and then jack, queen, or king, and then the method flip, face down, get index, that just returns the index of the card, if it's 0 through 51, and then the get bitmap, that's the one I want to that's the abstract class I'm telling it to implement later on. Now here's my card proxy here. Now underneath the hood I have a proxy card. Now notice I don't actually load that up right away here. In fact, I just set that to null, and I share all the same data with this class shares all the same data as a full-blown card, except it doesn't have the bitmap data, so it's a lighter weight version of that class, and it stands in the place of that other class until I actually load the bitmap data. So down here, what I'm doing is here in the get bitmap, this is what I'm doing is if the proxy card is null, then what I do is I go get the card, get a full-blown instance of the card, and I pass in this.index. And then if the proxy card is faced up, I go ahead and flip that for this instance. But down here in the card, during the constructor, I'm getting this right here. I'm getting the full-blown index. But the get bitmap is where I actually start loading up all the data. And you notice here, when I get the bitmap, it's actually doing a lot of the heavy lifting, and it's actually going out there and looking for bitmap data. And loading that data into memory and then returning that bitmap data here. So that's what I'm doing for this particular instance of the card. So and so it's a little bit much more heavier because it's got bitmap data in it. So that's really all that's relevant to the demo. You can see I have a partial card, I have a proxy, and then I have a concrete implementation of a full-blown implementation of that object, and the card is the proxied object, and the actual code that actually generates all this is down in the that uses all this is down here. The only one that's really of interest is whenever I go to get the bitmap data. Um, I'm actually going to be returning that bitmap data as a PNG, which is right here. So if they call something back and they're requesting an actual PNG graphic, and then so if they request a card, then I'm just returning the image bitmap data as a PNG file, and just returning that back to the browser, and so it can display it. So let's flip over to Chrome and play a little blackjack here. Gang 4, and let's pull up my proxy here, proxy.php, and then the dealer dealt a new game, and I have two options of hit or stand. It's only worth 14. I'll hit it, and I busted, so the dealer wins. So if I deal again, I only have 10. That's 19. But the dealer busted, so I won. So you can sit here and play blackjack if you want to, using my little game. Player busted, deal again. Hit, I busted again. The dealer's whipping up on me. I think I'll stand on that. That's pretty good. Dealer has the highest score. Darn, he beat me by 1 point. No, dealer's pretty good. But you can see here, I've implemented the game of blackjack using inside of that I have the proxy pattern going on. So just kind of a simple way to demonstrate it, but I had too much fun writing this demo, so you can play blackjack whenever you download my code samples and load this up inside of your web server, whatever that may be. Well, this about wraps it up for creational patterns and structural patterns in PHP. Well, we're not done yet. We still have to cover the behavioral patterns in PHP, and this is continued in part 2. The behavioral patterns are going to talk about how objects communicate and interact with one another, and we're going to see how these play out in PHP, as well as look at some new cool APIs and libraries that are available in PHP in part 2 of this video. So go ahead and flip over on WintellectNOW to part 2 and enjoy part 2 of PHP and design patterns there.